Login accepted.
So, good afternoon. It's been a long day, right? Definitely, yeah. Okay. I'll try not to run too long or too boring. If there are any questions, just stop me. We can also turn this into a discussion at any point in time if you feel more like that. But let me kick off about why is it always DNS, TLS, and bad configs? And who feels very, very much at home with this title already? Is that the experience some people have? Some? Okay. Let's see why and how and what. So for me in my head, I have this from Harry Potter, when McGonagall says like, why is it always when something happens that it's the three of you? And for me, this is where DNS, TLS, and bad configs are basically standing there and always wondering like, why is it always us? And why is it always that we are doing something or we are in the middle of an outage? So this is kind of like the picture that I have in my head when things are going south. Let's take a look at some examples of why that is. So DNS, I picked one example from Akamai when stuff went very much south for them, when they had a DNS misconfiguration and things were not reachable and they had a pretty bad day. I also have my own story around DNS. So a long time ago at one of my previous companies where I worked as a startup, we were moving from one DNS provider to another one, and we had multiple domains, and we were moving to Amazon Route 53, which was pretty new back then, and I was copying the name servers, and unfortunately I was copying some of the wrong name servers. And then obviously if you have the wrong name server in there, over the next 24 hours, which was the default timeout that was set, the domains would just disappear and not resolve anymore. And then you can just watch as stuff disappears, you can change it, but then you have another TTL of 24 hours, so you can then wait and pray that stuff will pick up quickly. But for us, luckily it was a weekend, and those were not super important domains back then, but it taught me the fun of DNS, that if something is propagated wrong and has a long time to live, it's potentially down for a long time, and you can just helplessly watch as servers cache bad results and will not have anything reachable. So that was my personal DNS experience, and I have since then become very careful when copying any DNS settings not to copy the wrong ones. And also I have since then shortened the DNS time to live mostly, because I don't want to wait another 24 hours until my fixes appear. And then there is TLS, which is always fun to configure and get right. One of the companies that has been recurring topics in here was Azure or Microsoft Azure, which they had at least 2 incidents where expired TLS certificates internally took down large parts of Azure, and they did it not just once, but at least twice from what I remember, and it took them a while to actually rotate all those certificates and figure it out. And it's like one of these annoying mistakes where you always say like, oh, somebody will do that in time. Maybe you've heard from Germany, they recently had the POS systems, like the card payments. They had a big outage there because they also had an expired certificate. I mean, it's already a wonder if you can pay by card in Germany in the first place, but those who had actually a POS were still down. So expired TLS certificates are unfortunately another common thing. And then you have bad configurations, which are almost like the king or queen of outages. Does anybody remember last October when Facebook was out and all of the Facebook things like WhatsApp and Instagram and everything, and that was a bad configuration? And it showed as DNS, but it only was the way that it showed up, because I think they had some check if something was reachable, and if not, they would reroute the traffic through DNS, and that failed, and then it was just unreachable. And allegedly, everything they were doing was built on DNS, so I think even the access to the building required DNS. And then there is this story that they used a chainsaw or something like that to actually get into the server room to reconfigure by plugging in, because there was no other way to get there. So it doesn't always get that bad, but bad configurations can reach interesting heights. Or maybe just 2 days ago, there was a Cloudflare outage again, where they had, ironically, they had a long-running project to increase resiliency on our busiest locations. and then they took down their busiest locations with that, which is a bit unfortunate, and that's what their network traffic looked like. So this is all of the network traffic that Cloudflare has in general. And then in the middle of their outages was, well, less than half was being served anymore. So those are all bad configs and the fun that you can have around that. So I call them the horcruxes of IT, the things that always go wrong and that you try to overcome to get to a better state. So what do you do with the horcrux? Yeah, you need to find the thing to fight it, right? So in Harry Potter, it's like where, I don't know, the book, you need the tooth of the snake or whatever to fight it. What are our tools to fight those outages? So my theory, and that's what I want to show you a bit, is that health checks are very effective as finding a lot of these things quickly or relatively quickly. And that's what I want to dive into about health checks. Who is generally using health checks? Some pingdom, whatever, maybe. Who is using their users as health checks? Who is using their users as health checks? So you wait until somebody cries on Twitter or something like that. That's normally what Microsoft does, or allegedly that's how Microsoft beta tests Windows releases, that they just release and wait what happens. So there are these ways to actually avoid health checks or some automation, but let's avoid doing that today and see what we can do. And I think in my mental model for how to structure health checks is you can have it like outside of the network, on the network, and on the host. And all three in combination basically give you a different point of view and try to find different issues in your system, if there is one. So let's say outside of your system, let's assume you're running, I don't know, you're hosting on GCP or AWS or whatever, and you basically want to take the view of your end user, and your end user is somewhere on the internet. So maybe we run a cheap server on, I don't know, DigitalOcean, Hetzner, whatever you have, just something on the outside to try to reach the server that you're running. That way you can check, like, does DNS work from another provider and on another network, and is it really configured correctly? Is the most outside lying firewall configured correctly? Does your load balancer work? Is the network generally reachable from the outside, or did some big digger cut through some cables and nothing is reachable anymore? And is the service generally available? So all of these you can basically see by having this view from the outside and checking how things are going. And then you can do similar things on the network. I mean, you could, for example, do TLS from the outside, but it should normally not really matter from where you check TLS. It's mostly a check like, how soon will TLS expire, and then get a notification like, oh, TLS will soon stop. You can check from inside the network just to have this difference, like, is it reachable from the outside or the inside? And if, for example, the big digger got your internet cable, then you might still have the health checks that work internally in the network, but not from the outside. You can also check the service availability, and what might be interesting to check the difference in latency. So you can actually see what is the latency within the network and on the outside, so you can then blame something on the user side or something on the provider side to the internet out of the data center, so you actually can pinpoint where the problems are. So by having these two different points of checks, you see the difference in them as well, and to get a better overview. And on the host, you can again check the service availability. What might, for example, be interesting, you have misconfigured your firewall and the service is running locally, and if you ping it locally, you will see, okay, the service is running itself, but I cannot reach it from the outside. If you only run the scanner from the outside, you would think the service died and is dead. Whereas if you ping locally and you see, oh, locally I can reach it, but not from the outside, it will point you that something is, or towards that something is wrong on the network. Potentially the firewall, something on the network, whatever it is, but you can basically see these differences in point of view to actually figure out, like, where in all the things that I have running to get to the end user, where is the breaking part, like, until where can I reach something. You could, for example, if you run a reverse proxy like Nginx, like, let's say you have a Java application and you don't want to expose it to the outside, you have a reverse proxy, and the reverse proxy dies. if you ping the Java application, let's say that runs on port 8080 as a classic, and you proxy with the reverse proxy on port 443 with TLS to that. If you ping both the Java app and Nginx, and for example Nginx dies, you could very easily pinpoint that, oh, Nginx is the thing that is down, not the Java application behind. Or the other way around, that you could reach Nginx but not the Java application. And again, you would very quickly figure out like which part is actually down in your system. You could check the database access. It's also a classic that you misconfigure the firewall on the database server, that your application cannot reach the database anymore, even though the database is running. And again, you could compare the latency from that point where you're running to all the other things where you're checking. So by having these three checks, one from the outside, one on the network but not on the host, and one on the host, for me, these are like the three simplest points from where you might want to run a check, just to get these different perspectives, and then by comparing where is something failing, how far do I get with my data, and kind of like pinpoint what the trouble is. And once you have pinpointed where like things are failing, you can then start the usual debugging. What is normally the first thing that you start when you debug? Probably maybe you look at logs, or you just call a colleague. That could also be the case. But you start somewhere to debug, and ideally you can pinpoint it that you even know like which logs are the ones that I want to start looking at, or which colleague do I call to help me out on this one. So why am I talking about all of that? So I work for Elastic, the company behind Elasticsearch, Kibana, Beats, various other products, and we're doing some health checks as well. And that's why I'm kind of like got into that model, like how would I set up my health checks, and how do I kind of like check out my entire system. So just to give you a quick view of what that looks like, and we'll do it in practice afterwards as well. But we call them monitors, and you can see in my system I have a couple of ones that are up and down, and you could then have the long list of things that are up or down, and you could filter only on the relevant ones. It can also tell you something like TLS expiry, but before we get into that, quick configuration. So for health checks, to keep it very simple, I basically use 3 levels here. So first we have ICMP, just to check is the entire server available if you have ICMP enabled. So here I'm just using on my server, and as you can see, this is a demo, so I'm always using Sierra WTF as my domain. How frequently am I checking the ICMP here? Who remembers cron syntax? Yes. Every 5 seconds, I'm pinging the host to see is the host still available. Then I'm checking through TCP. I'm checking, I don't know, MySQL and Postgres. Let's assume I have both of these running on the DB server on their posts. And here I'm using a slightly more readable syntax, but it's the same interval every 5 seconds. And then I'm checking my server, where I'm again saying every 5 seconds, just check the status page or whatever your server is, for example, exposing. And all of those would then check the result, like can I establish a TCP connection, or am I getting a response code? And by default, it would expect a 200 or 201 back from that action, rather than a 400 or a 500. 300s you would need to configure explicitly, like how you want to deal with those. Why do I even need TCP? Don't I always want to use HTTP? No, why not? Yeah, exactly. So if I have a database that doesn't speak HTTP, then I will need to just check the socket if I can reach TCP. It doesn't really give me like the insights of like what is the response code, but it will at least tell me that I can reach something there and it's responding in a reasonable amount of time. Whereas HTTP, of course, if you can, will make more sense because you get a response code and you have a better insight in how that behaves. You can also check for TLS certificates. So what is quite nice, that automatically, as soon as you use HTTP and it has an HTTP connection, it will tell you then where the certificate is coming from and until when it's valid and how old it is. So you have an overview and hopefully can rotate your certificates in time. But of course, you will always forget the most important domain to put there, and you're not pinging that. But for the next time, you hopefully add it to that monitor, and then you will get alerted before it is expiring, ideally. And you can also do some slightly more elaborate checks. So for example, here I'm actually saying I want to run not just like a 200 response code, but I want to run a post on that add endpoint, whatever that add endpoint might be. I could say, for example, oh, I have some specific body that I send it with a content type, and I expect this to respond with a 200. And in the body, it needs to have saved as a response in the body. Only then will this check pass. So you can build some slightly more higher level checks, not just like, oh, it responds or it's available, but also the functionality is kind of there. And then there are synthetic monitors, or monitoring, which is also a hot topic. Who has heard of synthetic monitoring? Nobody? Okay. So it's basically simulating from a headless browser a user flow. The most common system to underpin this is Playwright, which we are also using. And the idea is generally, rather than for your users to tell you that this workflow is broken, like you would run a very common workflow continuously for your users. So for example, if you have an e-commerce site and you have a shopping cart, then you would have a workflow where a user can put something in the shopping cart and they can go to the checkout page and they can actually pay and do the checkout. So that would be a flow that you run like once every minute or so. And ideally, even if something is down or you have a bad deployment, you could see that something is wrong before your users start shouting on Twitter, and you are kind of like ahead of them. Unless you're lazy and want to use your users as the availability monitor, but that's maybe not the right thing. And Playwright is looks something like this. It supports a couple of languages. I think TypeScript and JavaScript are the most common ones, but I think you could also do Java and Python if I'm not mistaken, though I've seen very few examples of that, where you could say, I'm going to this, whatever, test.com domain, let's say, and then I'm asserting that there is a specific placeholder text, and then I'm checking that. So this is very simple just to fit on a single slide, but it could be much more complicated. You need to authenticate, you put something in a shopping cart, you go to the checkout page, you actually you run a simulated payment process. You could run through all of those and always check, like, do you get the expected response back from those? And otherwise fail. Or, of course, you can use code generation. If you don't want to code all of that, you could just start this with npx playwright codegen and then the domain you want to test. It will open a browser. You can just click around and it will try to record what you have clicked around and put that into code. You can then fine-tune the code and then continuously run that every minute, 5 minutes, whatever, or after every deployment to check how things are going. So you don't have to write all of that code manually because that might be a bit cumbersome, but you can just with codegen just generate something and then fine-tune the generated code for you. So it's a bit simpler. Cool. So since we have 10 minutes or so left, I have a very simple system where I have something up and running just to show you the thing in as it works. And I only put like one failing domain because I think I didn't set up that CNAME. So this one is down here. I am pinging one backend service here, and I have my web server here. And just to show you that something is moving, I will say like auto refresh every 5 seconds. And let's stop that just to see that something is and let's see, or actually I should have shown you the page before when it was up, but okay, this is not working anymore as it should. And ideally, yep, it just happened. It will then shout that it's down. You could set a status alert on that, and you could then say like, send me an email, a PagerDuty, a Slack, whatever, if this is down, to make your life simpler. And that's pretty much the entire idea of that. And then based on where the alerts are coming from and how they are structured, you will hopefully get a very quick idea of where things are down. Just to show you the code, and let me start it up again so we can actually see this is working again afterwards. this is the file I want. So here I kept it very simple for our use case. So this is just doing every 3 seconds every 10 seconds with a 3-second timeout. I'm checking that my web server is still up. And then you can also enrich that with a couple of things. For example, in the underlying raw document, I'm adding like cloud provider information, so I would know in which availability zone is this running, on which internal IP address. I get some host metadata, and I can also say where is this check running, so I could draw that out on a map to see like from where is something slow or failing. So you have an easier overview of like where the pingers are failing, so that you can actually figure out what is the thing that is wrong. And with that, it has automatically refreshed, luckily again, so it came up just as expected, and that's pretty much all that is to it. And then you can make your rules arbitrarily complex, I want to say. The TLS certificate manager that I've mentioned before, you can see these are the 2 services, and I didn't need to configure anything explicitly in here. It just knows if it's using HTTP and pings an HTTPS endpoint, it will automatically extract the certificate and generate that page for you. And it will tell you where the certificate is coming from, how old it is. So you can see I just spun up the demo right before this talk. And you can then see if it's okay and how long it will be still valid until you need to regenerate your certificate. And then hopefully your users will be happy and nothing is breaking. Any further questions to that, or so far so good? Okay, cool. Sorry, yeah, please. So. Yes. Yes, so if maybe I should be a bit more explicit about that. There are of course many ways to do that, but the tool stack that I'm using here is our own. So this, if you've never seen it, is Kibana, and yeah, this is from Elastic. We have all of these observability tools in here, and one of the things besides logs, metrics, and traces, which are kind of like more common in observability, the health checks or uptime are also something that we have added in here, and which are just available and built in. And then the thing that is running the checks is it's called heartbeat. By the way, be careful, because heartbeat is a very overloaded term. So for example, if I would want to see the status of this service, it's heartbeat Elastic, if I'm not mistaken. So sorry, what am I missing? Service. What? Service heart. I'm sorry. So now, so don't be confused. The service itself is not called heartbeat because there are various heartbeat systems out there, but we called ours heartbeat Elastic, just to make that or differentiate it. And what we could finally look into, and I hope I have that edit here. Let me see. No, I didn't add the right index pattern. Give me a second. Stack monitoring, data views. This is just to add the view of this data set, just to show you the raw data here as well. So these are all the pings that are running, and you can see these are very even because they run every 5 seconds or whatever I've configured there. And then you can look into the underlying data, and you could, for example, see that this was the health check on this Kibana Xera WTF, which I have not set up. So it's telling me no such host, so this will tell you very quickly that, okay, this is actually failing on the DNS level already. It's trying HTTP. I have enriched that with the host architecture. What is also relevant is that this is running on cloud. Is that large enough for everybody to see? So you can see which cloud provider, which region, which instance ID, just to make debugging a bit easier. So you can enrich all of that information if you want to. You don't have to. It could make your life easier. What might be interesting is that you want to filter out what is working and what is failing. Let me go to another document to show you one that is working. So you can see here, this one is the health check that is working with the right certificate. So with that, you could then say like, okay, or see, this is the relevant information here. And by the way, this has a lot more information which I failed to show you. This is also doing stuff like host enrichment, and then here you can actually see this was the check that I was running. So this is the bytes that I was getting back, the hash of the page, so you could also see when a page changes, and lots of other things that you can all collect here if you want to, if it helps you debugging. And then you can also see where this was running from. So you could then, for example, say like, only give me the checks from one specific location or not. And at the end, you could say, or you can also see the TLS certificate or certificate details, etc. So that's pretty much what you can squeeze out of some health check. This is the full enrichment, so it wouldn't need to include all of those details if you don't need them. But just for the demo effect, I included all the features. That was a long answer. But all clear and good? Cool. Sure, please. Yes, exactly. Yes, so it's a good point. Let me run through that again. So you have the heartbeat is like the Go binary that is running, that is extracting the information. And then here it will tell you, if that wasn't cut off, it would tell you that it has stored X events in Elasticsearch. Elasticsearch is storing that raw data that I've shown you here. And then in Kibana, you have these visualizations. You could build your own, but the ones under observability and uptime, those are already built into Kibana. So this is not like a custom dashboard that you would need to add or build, but these are like applications that are built into from the start. No, so the heartbeat is not a jar. The heartbeat is a Go binary. So it's like a process that runs on the host where you want. So the heartbeats you would run on the different servers from where you want to scan. They would then send to a central Elasticsearch instance to store the data, and then that Kibana instance can visualize what is happening. Yes, so since I'm lazy, I'm using our own cloud service for Elasticsearch and Kibana, but you could run all of that yourself, and it's free to do, so go wild. So to wrap up, I always try to say that health checks are cheap, fast, and give you a nice overview, and that they're a good addition to observability, because a lot of observability is otherwise very much focused on logs, metrics, and traces. That's also what OpenTelemetry is doing nowadays. But I think that health checks are often kind of like an easier and cheaper solution to actually see what your users are experiencing, rather than building in much heavier and more complex tooling. It's one of many building blocks in there. And synthetics you can add, but I would be careful, especially if you change lots of things in your UI. They can be a bit brittle, and then it's like a whack-the-mole problem of like updating your health checks from the UI side, whereas the just ping the service and see if some REST endpoint is there is a much more stable thing normally. That's also much quicker to get up and running. And with that, I think we have 1 minute left. Any final questions? Yes. Yes. So no. So the Elasticsearch instance I would centralize in Kibana, so you only run that once, and then you have these agents, the heartbeat, that basically collects the information that can run on wherever. Yes, they should be somewhere else. Otherwise, you have the classic problem of who monitors the monitor. That if something is down, then yeah, you're not winning much. So ideally, it's not on the same hardware, and maybe even on a different provider or whatever, just to avoid those overlap issues. If you want to have stickers, take some stickers. I'm always trying to take a picture with you to document that I've been working today. You can all look very tired because it's been a long day. Or you can wave as well. Okay, I'm not really getting you into my picture. It's fine. It's been a long day. Thanks a lot. If you have more questions, I'm here tomorrow and the day after as well. I'm happy to answer any questions. Thank you.